Okay, so we are looking at this video, we're looking at the last section of chapter 2, section 2.8, and we're doing some function operations. So in some parts, it's just kind of a new notation way of combining, subtracting, multiplying, dividing operations or functions. And then the next page or two, we'll talk about the composition of functions as well. All right, so functions operations, we've kind of already done this before. In past examples, we've looked at the cost of creating X items, right? Fixed costs, each item costs $150. So the cost function, it's function C of X, is 150X plus $2,700. All right, that's the cost of creating X items. The revenue for selling X items will be 280X. So R of X is the revenue, and that's $280. Now, to get the profit, we simply subtract the two, but we have a new notation. So this R of minus C of X looks like we're subtracting an R and a C in here, but really it's the same thing as just R of X minus C of X. It's just another way of sort of more condensedly writing the operation of these two functions. So instead of subtracting them like this, we'll write it like this. All right, so we can add two functions. So we say f plus g of x is the same thing as f of x plus g of x. We have f minus g of x, and that's the same thing as saying f of x minus g of x. We have f times g of x, and that's f of x times g of x. And lastly, we have f divided by g of x, and that's f of x divided by g of x. Of course, where g of x cannot equal to 0 because that would make the composition, the combination of the two functions, that operation would be undefined. All right, so let's use these ideas in an example. So here are two functions. We have f of x and we have g of x. Here we're evaluating them at a particular value. Down here we're going to use the expression. So for these we should get a result that looks like a number or some kind of fraction or rational expression, something like that. Down here we'll get expressions. All right, so let's look at example 1. What is f plus g of 1? All right, so that's, again, just going to be f of 1 plus g of 1, right? So we put a 1 in for x of f of x, and we'll get, let's see, let's put it in. We get 2 times 1 squared minus 1 plus, now we look at 3 times 1 plus 4, which is the g of 1. So we have f of 1 plus g of 1. And so that's going to be what? 2 minus 1 plus 3 plus 4. And that looks like it should be what? 8? All right, so like I said, we're going to get numbers for these first ones. Here we're evaluating it just as x, so we'll have expressions down here. All right, f minus g of negative 3. Again, I would say that you should probably pause your video, try these, and then play the video back. All right, f of negative 3, so that's going to be 2 times negative 3 squared minus 1. Be careful, minus, let's put a parentheses around that, 3 times negative 3 plus 4. Well, not a parentheses, but a bracket. So you got to make sure we're distributing that negative to both those things. Common mistake there. And so this will be, 18 minus 1. This will be negative 9 plus 9 then, because the negative out in front, and then minus 4. So it looks like we should get, what, 27 minus 5, so we should get 22. All right, this one, f times g of 5. So let's put 5 in for this. So we get, I'm going to do this. We have 2 times 5 squared minus 1 times 3 times 5 plus 4. All right, so that'll be what, 49 in there. All right, 25 times 2 and then minus 1, so 49. And then that's times, what do we have, like 15, 19? All right, and so if we multiply that out, we should get something like 931. All right, part D then. It's f divided by g of 0. So f of 0 divided by g of 0. So we got, let's see, 2 times 0 squared minus 1 over 3 times 0 plus 4. That looks like negative 1/4. Okay, so again, these all had numbers. I think you'll see the next ones don't. We're going to be left with expressions because we're not told what to plug in for x. So this will be, again, pause the video, try these, and then we'll resume the video. We have 2x squared minus 1 plus 3x plus 4. And so we really just want to combine like terms there. Oh, sorry, I'm looking at our old functions. I have new ones here, sorry. All right, our new functions, these are the ones we want to use for these. So we have x squared minus 3x plus 4x plus 5. And now we want to just combine like terms there. So it's almost like less work here because we don't have to evaluate it at a particular x value. So we have x squared plus x plus 5. All right, the difference, that's going to be x squared minus 3x. Again, we want to put parentheses just to make sure that we remember to distribute the negative, the negative value. And so what do we get? We get x squared minus 7x minus 5. The product, so we get x squared minus 3x times 4x plus 5. And we just got to FOIL that. Looks like we'll get what? 4x cubed. We'll get plus 5x squared minus 12x squared minus 15x. And so that looks like 4x cubed minus 7x squared minus 15x. All right, and then the quotient of the two, that'll be x squared minus 3x over 4x plus 5. Nothing to reduce on that. I don't think we could factor in x out of the top, but there's no common factor on the bottom that we could reduce, so that's it. All right, and so in these examples, we were given an actual function for f of x and g of x algebraically, but we can also be given the information graphically. So you can see f of x is a linear function, g of x is an absolute, not absolute value, sorry, square root function. So what we want to do is think, okay, what is f of 4? Remember, this is the same as f of 4 plus g of 4. All right, so what is f of 4? So we go to f and 4, and we've got to figure out what that would be. So we're starting at 1, going up 2 to 3. We go to 5. We go to 7. I think you can see if we went over to 4, we'd be up at 9, right? So f of 4 is 9 plus g of 4, well, that's 2. So we get 11 for that one. So you're putting in, remember the x the value you put in is the x, the value you get out is the y value. All right, so f of -2, that's just -3. We're going to subtract then, oh, well, g of x is not defined at -2, so this one is undefined. All right, next one, f of 1 clearly is 3 times g of 1, which is 1. So this is 3. And then the quotient, I think you're going to see f of 0, that's 1. G of 0 is 0. This is clearly also undefined for a slightly different reason. G of x is defined at 0, but the ratio is undefined as a result. So it's in this one, g of -2 is undefined. We don't have that as part of our domain, but here we get a denominator of 0, which makes the problem undefined. We can also give you the information on part B here in a table. So for a particular x value, they give us the y values, essentially the f of x and the g of x for a particular x value. All right, so again, this is going to be f of -2 plus g of -2. You can see g of -2 is undefined, so this is undefined. All right, f of 4, that's 9 minus g of 4, which is 2, so that should be 7. All right, g of 0 is 1. F of 0 is 1, g of 0 is 0, so that product is 0. F of 1 is 3 divided by g of 1, which is 1, so this is equal to 3. All right, and the last one, they gave it to us algebraically. So f of g of 1, so f of 1, I put a 1 in for f, that gives me 7, plus, put a 1 into g, that's -1, so that should be a 6. All right, f minus g of 0, so f of 0 is 4 minus, and then g of 0 is 0. So that should be 4. All right, f times g of -1, so a -1 in here, that gives us what? 1 into f, and then g of -1, that is also -1, so that should give us 0. Oh, sorry, we're not subtracting, we're multiplying there. So that should be up. -1 into this, let's see, so that's going to be 1 times -1, and so that's -1. Sorry, I think I have too many negatives. I have a kind of glare on my screen here. So -1, all right, because we're the product. I was looking at this -1 thinking it was subtraction. All right, and then the quotient, f of -2, we put a -2 in here. That's going to be what? -2 over, I put a -2 in here, it's -2. And so that is equal to +1. Okay, so let's go on to page 2. Now page 2 is sort of a little bit of an introduction to something that we're going to look at a lot next year in Trig Calc. This is sort of the beginnings of something that we do in calculus. But it should look familiar. We did this in section 2.4, something called the average rate of change. So we have two points. We have an x and we have an f of x, right? So we have this point at x and f of x. And we go over a certain amount that we call h. And so this x coordinate is now x plus h. And then, so everything's kind of built on this x value. So we have x, and then we have this value, which is x plus h. We moved over. And so then this height, or the y coordinate, is f of x plus h, right? So we have the x coordinate of this point, which is x plus h. We plug that x value, x plus h, into the function, and we get out f of x plus h is the y coordinate for that point. All right, and so it really, if we think about this curve going through this, and we're just picking 2 points and drawing a line, we call it the secant line because it touches it in 2 spots, the curve at 2 spots, and then we're just looking for the average rate of change. So the change in the 2 y values divided by the change in the 2 x values, that's just the average rate of change. So what we do is we take this point minus this point. So x plus h minus x. And then we do at this y coordinate here, f of x plus h minus the other y coordinate, which is f of x. Now notice the x's in the bottom go away, and we're just left with h, which is the difference. All right. So if we're using this as sort of our definition for what a slope is for an average rate of change, then we're going to use that down for this function down here. So notice that this is one of the most fundamental definitions of calculus. So if we let h, so this is the average rate of change. If we let h approach 0, so h gets smaller and smaller. So this x plus h, again, h is getting smaller and smaller. This point is coming down closer and closer to this point. And so it's really super duper close to it, infinitesimally close. So instead of having the average rate of change, we have what's called the instantaneous rate of change, the slope to that curve at that point, right? This is the slope through those 2 points, average rate of change. But as the point comes closer and closer down this curve, closer to this point, P, then the slope becomes the actual slope at that point, tangent to that curve. And so that's what we call the instantaneous, the slope of the tangent line. So this whole idea is really going to be important more next year, but it kind of lends itself well into this function operations that we do here. So let's go ahead and run through one of these and see how that looks. All right, so on example 4, then we have this function. So this is, say, the curve. Like, we have a curve through here, f of x. So this is the f of x. Now we want to apply this. So we say m is equal to, and so we want this function evaluated at x plus h. So instead of the x, I have x plus h. So we have 3x plus h, quantity squared. So I'm doing this part here, right? The f of x plus h. So minus 2 times, instead of x, we have x plus h. And then plus 4. All right, all of that is just the f of x plus h. It's that function evaluated instead of at x, evaluated at x plus h, minus f of x, so we're going to keep going here, minus f of x, put in parentheses, so we remember to distribute the parentheses, the negative. So 3x squared minus 2x plus 4, and all that is just over h. Okay. Now, let's simplify this stuff, right? And combine like terms and see what happens. So here we get, let's not distribute this. Let's FOIL this out and then distribute the 3. So that'll be an x squared with a 3 in front. I've distributed the 3 to it. And then twice the product of the two things. So 2xh or hx. And then times 3, so that'll be plus 6xh, and then we have plus h squared, but that'll be 3h squared. And then distributing just that negative 2, we have negative 2x, we have negative 2h, plus 4, Then we have minus 3x squared plus 2x minus 4. All of that over h. Okay. Now something interesting happens here. Notice that the negative 3x squared cancels with the positive 3x squared. This negative 2x cancels with this 2x. 4 cancels with the 4. And now if you look what's left, everything that's left upstairs has an h in it. So we can cancel out one of the h's with that. So this will become, let's write it, well, let's go ahead and just do it the same order. So it'll be 6x, the h cancels, plus 3h, one of the h's cancels, also then minus 2, because this one, the h would cancel, and then everything else canceled away. So this all simplifies down to this. Now, what's great is, that's the average rate of change. Next year, what we'll do is we'll let h approach 0. So if h got infinitesimally small, then this whole thing will disappear, and what's left is something called the derivative, which is a key component to what we do next year. But for now, this is the answer, right? That's all we're going to do. We're not going to take what's called the limit as h approaches 0. We're just going to leave it like this. So those three terms are our answer, okay? All right. Next thing we really want to talk about is the composition of functions. So you'll have a couple of homeworks that deal with this. Just kind of have to use the formula they give us and just plug things in. And you just have to, if you do it correctly, a lot of the stuff is going to cancel. And so the denominator ends up becoming 1 because everything that's left has an h in it. And so it works out pretty nicely. All right. So real world example here. Suppose that you get a coupon in the mail from Jeans R Us for $20 off one pair of jeans. If you let X represent the original cost of a pair of jeans, then the sale price will be, of course, X minus 20. But don't forget that you'll have to pay 8% of the final price, 8% of the final price as sales tax to the government. So as a separate function, the P would be would be what you have to pay for the tax, and that will be well, actually not how much you pay for the tax, but it's 1.08 times X. So that's the final price. Once you've taken and evaluated how much your price was, then after you take your $20 off, then take that value and multiply by 1.08, and that will give you your final cost, or the price you have to pay. All right, so let's work through an example where the jeans are $80. So the jeans are $80. You take away $20, that's 60. Now you plug 60 into the function for P, and you multiply it by 1.08, and you pay $64.80. Now these two functions that you did, one, the output for one becomes the input for the next, can more easily be done if we do what's called a composition of the two functions. And so we can instead of putting 60 in here, instead we put S of 80. So we put this original function back into this 60 spot, right? And so then it's P of the function is 80 times 20, that becomes 60. And so you get the same result, but you don't have to do one operation and then another. You can combine them into this composition. Okay, and so now instead of doing the two functions, really we have this one function. And this will calculate the amount you have to pay for any amount of jeans, even if it's not just 80, but that's what you would do for any amount that you plug in. Okay, and so that's the key is now instead of having to do two operations, we do the composition of the two functions, and it's kind of written like this. it's the p of s of x. So you take the inside function, you put it into the input for the second function. All right, so let's look at some algebraic examples then. So f and g are functions. So the composition of the functions, it's more user-friendly to write it like this. It's f of g of x. So g of x is the first function. Its output will be now the input into f of x. All right, but just a quicker way of writing it, a kind of a newer notation is if we call it f of g of x. And so sometimes we kind of look at this, it looks like a multiplication dot, except it's more like a donut, it's hollow. So it almost looks like a little O. And jokingly, we sometimes say fog x as sort of a shortcut, right? It's just like fog x. All right, the domain of fog x is the set of all numbers x in the domain of G, such that G of x is in the domain of f of x. All right, so that'll make more sense when we go through some examples. All right, generally speaking, fog x and goff x, so f of g of x and g of f of x, are not necessarily the same thing. So up in this example, if we calculated the tax first, then subtracted $20, that would be different than if we subtracted $20 first and then calculate the tax. All right, so let's look at some examples. And again, the first couple we're putting numbers in, and then the next couple examples we're not putting numbers in. So these will be expressions, and these will be actual numbers. All right, so f of g of x. Sometimes students have an easier time if they, at least the first couple times, write it like this. So we're doing the innermost function. We're figuring out what g of 2 is. So g of 2, well, that's just 1. So this whole thing is just f of 1. All right, so now f of 1, we plug that in there. And so that's equal to the square root of 5. So f of g of 2 is square root of 5. We can also, again, say that that's fog 2, is just kind of a shortcut way of saying it. Okay, so now goff 5. So again, you might find it easier to think of it as f of g of 5. So what is f of 5? F of 5 is the square root of 9, which is 3. So this is equal to g of 3. And then g of 3, that's just equal to 2/3. All right, so goff of 5 is 2/3. All right, now let's try it with some expressions. So again, this is going to be f of g of x. You know, we can, instead of writing it like this, we can write it like this. So the first thing we do is we replace g of x with its actual function. So this is equal to f of 2x plus 5. And then this is kind of what we saw up here where we were putting in a binomial in for x. Same kind of thing that we're doing here. We are putting this binomial in for x in this other function. So that's equal to the square root of 2x plus 5, but that's minus 1, so that's plus 4. All right. So we're looking for the domain. So we have to look at a couple things here. So the domain, first of all, we got to know, is there any restriction on the domain for this part of it, right? So there's no restriction on x going in here. However, the result in here, this cannot be smaller than 0. So 2x plus 4 must be greater than or equal to 0. And if we move the 4 to the other side and divide by 2, that means x must be greater than or equal to negative 2. And so our domain is going to be anything greater than 2. So we'll say, so let's do this. Domain and then negative 2 comma infinity, right, will be our domain for this function. All right, this next one, this one could be written as g of f of x. And so first thing we do is we put this function for f of x into g. So g of square root of x minus 1. And now we plug that into this function. So we have 2 square root of x minus 1 plus 5. All right. So we have some limitations in this case. The limitations, again, would be centered around the square root. The square root cannot have a negative value. So for the domain, we have x minus 1 must be greater than or equal to 0. So x must be greater than or equal to 1. So in interval notation, again, we have 1 comma infinity. So that would be the domain. This is our answer, and then this is the domain that they're asking us for. Okay. All right, let's move on to page 3. Have that here somewhere. Okay, page 3 then. We're given two functions, f of x and g of x. Oh, sorry, can't see that. We're given f of x and g of x, and now we're asked to find the composition of fog x, or f of g of x. So again, if it helps, go ahead and write it like this. Kind of helps you remember which one goes into which. So g of x is first, and that gets plugged into f of x. So this is f of, and g of x is 1 over x. And so that gets plugged into that function. So we have 6 over 1 over x minus 3. And we want to simplify this. Again, if you remember from a couple chapters ago, I think actually back in chapter R, we simplified things like that by multiplying by x over x, the common denominator, right, when we have a complex fraction. So that ends up being 6x over 1 minus 3x. Okay, so that is our answer. And they're asking about the domain. So there's a couple things that we have to concern ourselves with. We can't have an x value that makes g of x undefined or f of x undefined. So this original thing that we plugged into f of x would be undefined if x is equal to 0. So x cannot equal 0, but also in the final answer, 1 minus 3x, that can also not equal 0. And so that means that we can't have a 1/3 as well. So x cannot equal 0. It can also not equal 1/3. 1/3 placed into this would make this 1 minus 1, which would be 0. So the domain, this one's a little trickier to write out. In interval notation would be what? Negative infinity up to 0. 0 to 1/3. And then it would be from 1/3 to infinity. So that's kind of how we exclude those. It's the whole number line from negative infinity to positive infinity minus those 2 points. So that's how we would write it in interval notation. All right, so what about this one now? Same thing, but instead of gof x, we're doing, instead of fog x, we're doing gof x. So this is going to be g of f of x, and f of x is 6 over x minus 3. So this will be, now we plug that into the other function, so that's 1 over 6 over x minus 3. And of course, that's just a keep change flip. So it's 1 divided by this fraction, so it's 1 times the reciprocal, so that'll be x minus 3 over 6. And then any restrictions on that? Well, the restriction in this case, this doesn't have anything that's bad in it, right? It's this thing, right? It's this, that can't be 0. So x cannot equal 3 in that case. And so then the domain would be what? Negative infinity to 3 or 3 to infinity. Okay. All right, example 3. Given f of x and g of x, let's show that fog x and golf x do not equal. Right, so we can what we can do is we can just do f of g of x, figure out what that is, and then over here we'll do maybe g of f of x, and we'll see if they're indeed equal or if they're different. So g of x, that's this function, so we have f of 2x squared plus 5x. And now we plug that into this function, so that's equal to 4 times 2x squared plus 5x plus 1, so 4x plus 1, with the other function plugged into it. And so that's equal to 8x squared plus 20x plus 1. And now let's do the reverse. This is going to be g of 4x plus 1. Now we plug 4x plus 1 into the other function. So 2 times 4x plus 1, quantity squared plus 5 times 4x plus 1. You can already see these are probably not going to be the same, right? But let's go ahead and keep going. I'm going to FOIL this out. Let's leave the 2 out in front still. 16x squared plus 8x plus 1. Let's go ahead and distribute this. 20x plus 5. And so this is going to be what? 32x squared. That's going to be 16x plus the 20. Let's just write that as 36x. That'll be 2 plus the 5. That's 7. So we can clearly see that this and this are not equal. So yeah, these fog x and golf x are not the same. All right, last example. Find a function f of x such that the composition of the function is this. So if you're thinking about before, see how we got one function plugged into the x value of another, right? We took this function, plugged it into this, use that idea now down here and write 2 functions, f of x and g of x, such that fog x would give us this. So pause the video and try that. So it looks like we plugged 3x plus 2 into that. So if we could rewrite this as 4x squared minus 5x minus 8, right? That would be the second function that we're plugging x into. So that would be the f of x, I think. And then what are we plugging into that, right? So g of x would be the thing we're plugging in, 3x plus 2. So that means that if we did f of g of x, we're going to take that function g of x and plug it into the x values for. So I don't really need these parentheses for this f of x, but I was doing that just to help you kind of visualize that this would be like the x and the x, right? The thing that's plugged in, that's the other function. Okay? All right, so your homework tonight is this. Do next class. Remember, times 4 is multiples of 3, times 3 and times 4 multiplies of 3, multiples of 4. All right, do next class.